going on, Algebra Bros? It's Mr. C here, and in this video we're going to sketch the graph of two basic log functions. Let's dive right into it. So it says sketch each function using transformations, identify the domain, range, asymptote, and the new location of 1, comma 0 if any. Repeat that 10 times fast, right? Anyhow, let's look at example 1. This is log base 2 of x. And that base of 2 is how we're going to start things out. This is a base a that's greater than 1. Now off to the side, I'm going to make a little mini table where the first column represents x and the second column represents log base 2 of x. So prior to any transformations, we should know that there are two immediate points that we can identify in this graph. Those would be 1, comma 0, and then a, comma 1, which in this case would be 2, comma 1. So I'm going to plot those 2 points, 1, comma 0 and 2, comma 1. And as we'd expect, with a base a that's larger than 1, we would see that the right end of the graph slowly increases to positive infinity. And to the left of the point 1, comma 0, we'll have an end of the graph heading down towards negative infinity. Now, notice that there are no alterations in front of the log expression as well as inside of the argument. So what that means is that there are really no transformations. We're just really supposed to provide a basic sketch of this function's graph. So that's why I have it filled in instead of dashed. So this would be my final graph. And a key point on it would be 1, comma 0. Of course, you could identify 2, comma 1 as well, but 1, comma 0 would be good enough. The only other thing that I want to add in here is the vertical asymptote, which is going to be the y-axis, since there's no transformations. That would have the equation x equals 0. So in terms of domain, range, equation of the vertical asymptote, and the new location of 1, comma 0, so there are no alterations to the function, so no transformations are really present here. So we can keep the domain as parentheses 0, comma infinity. In other words, the graph is entirely to the right of x equals 0. The range would be all real numbers. The equation of the vertical asymptote would still be x equals 0. And 1, comma 0 didn't relocate to a different point, so that's just still going to be at 1, comma 0. And that would be a basic sketch of log base 2 of x. So moving on to the next example, let's recall that the natural log of x is shorthand notation for log base e of x. And I mentioned that because the base here is e, which is a base that's larger than 1. Let's recall that e is approximately 2.7. And the reason why I want to do that is because when I generate my table for x, natural log of x, I know that 1, comma 0 prior to any transformations would be on the graph, and so would e, comma 1. So that's roughly 2.7, comma 1. So I'm going to go ahead and plot these 2 points, 1, comma 0 and 2.7. So I'm going to be somewhere between 2 and 3, a little closer to 3, and then go up by 1 unit. And I'll connect these 2 points in the following fashion. I'll start at 1, 0 and increase slowly to positive infinity while going through e, comma 1. And to the left of 1, comma 0, I'll curl the end down towards the negative part of the y-axis. And much like the first example, there are no alterations to the natural log of x's expression. So there are no transformations. We're just providing just a basic sketch of this function. Let's not forget that there's the vertical asymptote of x equals 0. And that would be the complete sketch. Let me just identify a key point, which is 1, comma 0. And as you might expect, the domain, range, equation of the vertical asymptote, and new location of 1, comma 0, if any, are going to be the same as our first examples. So the domain would be from 0 to infinity. Range would be all real numbers. Vertical asymptote x equals 0. and 1, 0 stays put, so I'll say it moves to 1, 0. Okay, so that's it for this video. I'll be including a couple of other videos for more complicated sketches. But as always, feel free to let me know if you have any questions about this one. Otherwise, thanks again for watching, and I'll see you in the next one.